Hey guys, my name is Kyle, and I am the basically math coordinator for Grade A Plus, and I wanted to share with you a couple of some notes that I've prepared and things to sort of give you reminders of just ways of sort of being a better tutor, and also some things to keep in mind and sort of little nuggets of information to help you understand what we are here for as an organization that's not just for the homework help tutoring kind of thing. um, so the first thing I want to say is, just keep in mind that there are lots of different ways of doing things and thinking about things. And not only is that helpful when it comes to explaining something, right? Trying to think of different ways to think about it, and maybe one of them clicks with your student, but also in the sense that try and um, show these different ways regardless, um, because it will just help the student apply the same thing to other things that they might be less familiar with, right? So you're building from the thing that they are more familiar with and expanding it to things that they're less familiar with, and also just getting them more used to getting outside their comfort zone, or um, understanding things enough that they can sort of translate it into something that they do understand. Let me share my screen real quick, and I'll give you a brief example about this. So, for example, say you're helping someone with algebra, or you're even just sort of doing this because that it's a useful thing for people to get more used to. Um, and so, say you're solving an equation that looks like this: 3x plus 1 equals 7. Now, the thing to keep in mind is a lot of times our brains will go more toward the pattern recognition, and they'll remember things or something that looked like this the last time and just immediately go for it, and they can solve it fairly quickly that way, right? So they would end up subtracting 1 from both sides, and then they cross that out and they write 3x, do the 7 minus 1 equals 6. And then from here, you do a similar sort of thing where you divide both sides by the 3, cancel those out, and then you do 6 divided by 3, and you get 2. Okay, so the sort of thing to keep in mind here is this is all fine and great. This is how it works. But there's a lot of things that students aren't always thinking about. They're just doing, right? Mostly with this cancellation, right? This plus 1 minus 1, and it just goes away. Why does it go away? Right? Well, because 1 minus 1 is 0. And so we're really getting a 3x plus 0 here. Right? But adding nothing to something isn't doing anything. So we really just write the 3x because it's simpler. Right? Same thing with why the 3's cancel. Right? These 3's here, they cancel because we have x, and it's multiplied by 3 and then divided by 3. Right? So you're undoing that. And so they cancel that way. Or think of it by going back to sort of what you did with fractions, where multiplying a fraction by a number ends up putting it just in the numerator. So this is the same thing as 3 times x over 3. And now 3 divided by 3 is 1. So we get 1 times x. But 1 times anything is just itself. So we get the x there. So understanding these steps and making sure they sort of recognize that is very helpful, and it is more likely to stop errors, right? Say we ended up with trying to get rid of the 3 first, and we divided by 3. Right? You can't just cancel these 3's anymore, because now the rest of the numerator isn't multiplied by this 3, right? We have something added to that x, not just multiplied. Right? So you can't do that. And I mean, really, the reason is because you can't separate this fraction the same way you can here with this 3 multiplied, right? There's an addition sign there, right? So part of it is sort of getting rid of errors, but part of it is also solving the same problem that looks different, right? What if we had instead 7 equals 1 plus 3x. It's the same equation, but students take longer solving this because it just looks different. It looks a little bit weirder than what they're used to, right? But if they can understand the idea of, all right, we are trying to get the x by itself. All right, let's sort of work from the outside in, right? We have this 1 that's added to it. So how do we get rid of that? Well, subtract it. All right, and then that goes over there, right? You do the computation, you get here. And now it's kind of the same thing, but it still looks different, literally just because the 3x is on this side, and it still takes them longer. They're used to looking at this side of the equation to find something to do, right? But, again, what's the objective? Well, the objective is to solve for x. Get that by itself. Currently, it's multiplied by something. So we can undo that by dividing by that something for the same reason that we just talked about, right? And then do it to both sides so you keep the same thing equal. And then you do that final computation to get x equals 2. Right? And maybe they end up writing it like that, but again, that's going to be equivalent to the more sort of common way they're used to looking at it. Right? So just keep this stuff in mind, and it can be good practice to literally just rewrite the problem in a more strange way. This also goes to rewriting things like, say you have 3x minus 1 instead. You could rewrite that as -1 plus 3x. See if they recognize that. See if they understand that, right? So all of these things are sort of things to think about when going through these problems, instead of just doing the problem, moving on, and it's done, right? And not only is this for their benefit, but it's also to slow down and make sure that they really are understanding it. Because a lot of times students will see you do the solution and then say, oh yeah, I get it, let's move on. But as soon as they come across something that's slightly different, or even the same thing with different numbers, they either forget they didn't actually understand because they didn't do it, you did it, or it's just different enough that they're not used to this stuff yet, and so they got it wrong, or they're not comfortable with it yet, right? So sort of presenting all of this and telling them about this is going to be useful, and working with these things and thinking it through, right? Using the brain. Why am I doing these steps? How is it helping? Is really going to do a whole lot of good work, other than just the brain going on autopilot and doing the thing that it wants to do or thinks is correct. Okay, and I'll talk about that a little bit more in a second. All right, so just thinking through things and explaining it, and even having them explain it to you, right? Why did you subtract that 1? Right? Why does it go away? Right? Stuff like that. Okay, so other things that can help are algebra stuff like this. Number sense is also a place where kids struggle a lot, especially fractions, things like that too. Right? So even also just using the calculator too. Some kids either are using the calculator when they shouldn't, not because it's bad to use a calculator, but because it is more helpful to get used to being able to do things yourself. Things get faster. You don't have to stop what you're doing, go to the calculator, put it in, go back, right? You're sort of losing some of the context and information, right? Because maybe you had to compute that number, but you're not done with the problem yet. There's more to do. And so if you can just immediately have that simplification or computation or whatever it is, you're going to be better off, right? So all of these things are things that either you can discuss with them or sort of hint at, or even just have them do regardless. So for example, say a student needs to square something, 3 squared, and they can't find the caret or the square button or whatever it is in the calculator. Well, even if they are, dead set on using the calculator, they still can. Just tell them to use the multiply button, right? Because squaring is taking something and multiplying it by itself. Now, some of these things might be obvious to us, but again, they're sort of used to the autopilot. Where's the thing? How do I put it in? And they're looking for the square button. They're looking for the caret button. They're looking for the thing that they're used to, and it's causing them time. They're getting at least a little bit upset. That's going to build up over time. Things like that. But just slow down, think. How can you get through this? How can you do this thing, even if it's just a simple operation like this? Right? And repeating this enough times is going to get them to that even more broader goal of problem solving, where, don't just do what seems right or do what you're used to sometimes. It can just be better to just think about what you're trying to do, and how to get through it, other than trying to do the solution exists. Because maybe you're getting it wrong, or maybe there's a better way of doing it, or maybe it's just taking too long. Okay, so anyway, sort of all of that stuff. So, and I've kind of been talking about this a little bit, but the idea is we want to motivate these students and congratulate them when they do good, and when they are doing well, and also pointing out these things to help them feel a bit more confident, and also understanding this learning process, right? A lot of kids are sort of anxious about math. They don't like being wrong. Um, they are frustrated when the problems are hard, stuff like that. But if we can continue talking with them and making them feel comfortable, and encouraging them to sort of work on this, and that it's okay to be wrong, and you should be wrong more often now so that you can get comfortable with it, because that's not going to go away. And often there are benefits to it, like learning and better understanding something, right? Don't be afraid to just do stuff, ask if something's right or wrong, stuff like that. It's fine, right? All of these things are things that are important things to understand. And sometimes it's not being made explicit. Yeah. Uh, so another thing that kind of keep in mind about this stuff is a lot of times you can use the tutoring as an avenue to get some more uh, useful, even like life advice and things like that. Right. For example, if you've I kind of talked about this earlier, but if you have a problem in life or whatever it is, don't just give up and be sad and move on to something else because you don't want to think about it. Uh, right? Because that's only going to make things get worse. For example, in the homework, you don't understand it, so you don't do it. You're embarrassed or anxious, so you don't get help, and then you start falling behind, right? And that's really the thing, is the problems compound themselves when they're not solved. Well, not even solved, but like worked through and gotten past instead of just ignoring it. Right. The same thing is in life. You have things to do. You have errands to run. Getting the practice of just doing something and finding a way to get yourself through it, or having someone to encourage you to take those steps into that instead of just shutting down, is going to be useful. So things to keep in mind there. There are also some things that are even more directly applicable, that are like a little hidden, so to speak. Say you're dealing with, I don't know, maybe decimal form, or even just writing out numbers as is, or polynomials, for example. I guess I'll do both of those things that I said, like say x cubed plus x. If you're going to work with this with like long division of polynomials, you might write this as x cubed plus 0x squared plus x, right? Putting in that little placeholder guy so that you can work with this in the long division and yada, yada, yada. The point isn't for that specifically. It's more about the fact that this placeholder exists, but it also exists in numbers, right? The number 601, it has 1, 1, 0 tens, but we still put something there, and 6 100s, right? But we have this little placeholder here. Right? But things like this, you can even extrapolate that to, I mean, this is a good habit and a thing to get into, because we even do that ourselves, right? Say you're cleaning the kitchen or cleaning your room or whatever it is, and uh, you have something and you put it somewhere, but you don't fill up the whole space that it could be because there's something similar that is maybe in use right now or it's temporarily lost, you can't find it, or whatever. You sort of leave space for that thing, whatever it is, a pen, a notebook, whatever it is. You set aside space for that because it's useful to consider that you'll need that space when you eventually have that, or that's something that needs to be considered, right? Same thing here. We need to consider this sort of x squared, or our whole division algorithm here, and how we do this is sort of going to get messed up, right? So you can even make analogies with the actual math content and what's happening, and explaining why it's useful and how that can manifest itself in real life, and be these real world skills and things to consider. So I mean, broadly what I'm trying to describe is that not only are we here to help them get better with math, whether that's with their homework or helping with remediation, getting better with some of the past skills that they didn't do so well on in previous grades, and now it's being a hindrance to them, making them feel more comfortable and more confident in themselves, right? That's important, just in general. And you can start building that and start getting them used to dealing with those things with mathematics, right? You can sort of relate these concepts to real life. All of this stuff is important. I'm not expecting or thinking it's going to happen all the time, but just if these are things that you're aware of, keeping in the back of your mind and understanding that this is more broadly what we're about, it's not just about helping them get the homework done on time and stuff like that. You'll you'll be a better fit for what we're trying to do, and also more importantly, it's just important for these kids. You're you're more of a role model as well, instead of just a tutor, right? Just another positive adult influence in their life, right? And that is a good thing. Okay. Uh, all right. So that's sort of it about that. If you have any questions about what you can do to help with your student with math, or you can't think of a way of making something fun, come talk to me and we can work together to figure something out. With math, it's also kind of tricky because sometimes, uh, especially with the younger grades, there are some things that are just you repeat it until you get used to it, and you can do it, right? Basic addition, for example. You just do it, even if they understand it. It might be slow and they need to be fast at it. Sometimes there isn't a whole lot you can do with that, but you could find something to do on the computer for them that turns it into like a little bit of a game. And even just a little bit of something different from just worksheets in class is enough to make them more interested in doing that. For example, our IXL program, having them do activities and practice in that is nice because they have the little point system and there's ribbons, and sometimes that's just enough of a thing to make the kids do the practice and be interested and motivated in some sense. Yeah, so let me know, and also use our resources. If I go to Safari here, you should get a link of this. If you don't, the URL is there at the top. But hopefully someone will get this to you in some information email. But there's a lot of stuff in here to help you with your job of teaching and finding things to do and help the kids once you know what they're doing in class, what their weaknesses are, stuff like that. So please, take a look at some of these things. There are more things and more resources in the overall folder where this is. This is just a smaller, condensed version of stuff that I like to at least try to reference first because it's either easier to access or it's more interesting to me or I'm more used to this. Um, you know, but I mean, sometimes it's even useful to have to find stuff like this to do if they've already finished their uh, homework or whatever, and you don't want to just sit there and you don't know how to bring up more practice problems. I mean, IXL can help with that, but you could even just have these productive thinking conversations because thinking is it's so huge. You know, if you can't think, then you're already at a big disadvantage in the world. And not only that, but also communicating, right? You need to be able to communicate with people. And so sometimes communication can be the sort of the goal of some of this is too. For example, I love this sort of thing, like which one doesn't belong. Here, let me click this link and show you one of them. I don't know, this one. You can talk about this sort of thing where there's slides of a couple of things and you say, okay, which one doesn't belong, right? And have a conversation about it. There's no right answer. There's no wrong answer. Just a way of thinking about things, right? Maybe the number 3 doesn't belong because it's a small single digit number. All the others have more digits. Maybe 31 doesn't belong because it's the only one that's not divisible by 3. Uh, right? Maybe 27 is actually the only thing that belongs and nothing else does because uh, it's a perfect cubed, right? It's 3 cubed. Maybe 1, 2, 3's, the thing that doesn't belong because it has that sort of sequential going up thing. Maybe 31 doesn't belong for a different reason because its sort of numerals go down from left to right, right? 3 and then 1 is lower than 3, right? So we're sort of talking about these things, and it also builds the math vocabulary that you might be used to, but it is not as practiced with the students, right? Thinking about these things as greater than, less than, place values, number of digits, divisibility, right? Even just the vocabulary and getting used to talking about this and getting the brain thinking with these more open-ended questions is useful and also fun. You can also involve other other students and get them talking with each other. So yeah, this is what we're about and things that you can do that are good. I especially uh, want to shout out Desmos and GeoGebra. Well, I guess Desmos has a lot of the GeoGebra functionality nowadays too. Let's just sort of go to one of these. You can also just go to desmos.com and there's a search button for some of these. I'll show you what I mean. Let me just click one of these in the links. But at the top of this page, there's this search bar, right? You can literally just search the topic, maybe even the grade level, stuff like that. But you can just pop it open, and then there's even a preview button because if you're only working with 1 or 2 kids, you don't need to make a whole class and assign it and stuff like that. You can just do it and talk about it. So you just sort of go through, and they got little teacher hints at the bottom there, and things to think about. In this case, it looks like you've got bears on, oops, you've got bears on this scale, and the triangle is the balance, and it's talking about the location of that balance is the average or the mathematical mean or whatever. So here 6 is the average of 1, 8, and 9. You know, but yeah, so anyway, this is sort of the idea. There's all sorts of fun stuff on here. There's also marble slides where you sort of spawn these marbles that go down the graph function and collect these stars. It's a fun game. They've got sorting things where you literally sort either pictures of graphs and or vocabulary and other stuff into like sort of like flashcard piles to talk about, oh, this is related to this or this matches with this. All sorts of good stuff to find here. So I highly recommend this and a lot of these other stuff in here. There's also lower level things too, like maybe you're trying to get them to practice or even learn some simpler algebra and equation solving. this where is it? This splat is really great. Unfortunately, I think it's all download stuff, so it's not great for showing you right now. But you know, it has dots and then some splats covering up other dots, and it says, "Oh, in total there are this many dots. How many are under how how many are underneath the splat or whatever?" To us, it's a simple subtraction thing, but it sort of presents it in a different way. You can talk about it differently. It's easier to visualize. And then you can take that and translate it into maybe writing an equation, uh, and then solving the equation and showing the relationship between the two, right? So I'm not saying all of this stuff to sort of make it seem like this is such a hard job or anything. It's not. I and everyone else are here to help you. Here, I guess I don't need to uh, share my screen. This is just to help you be a better tutor and role model for the student, things to think about, and a little bit of a better understanding of what we're here for here at Grade A Plus. Okay, I mean, I could talk forever about this kind of thing. Feel free to reach out if you need help or want to talk more about this stuff, and we'll get you sorted. But yeah, again, my name is Kyle, and welcome aboard.